Well, hello there. I just finished filming a little video on putting connectors on some LED boards that we received from China, and I thought I would also do a quick little video about our Sexy Girl table. Now, behind me you can see the back glass for the Sexy Girl table. Right behind me there is an image that's probably not okay for YouTube, so I'm really not going to move and let you guys see that, but I might make a shot of it and fuzz it out a little bit or something so that you can get a whole view of the Sexy Girl back glass. It is a pretty nice piece of artwork. Mike told me it actually came from a Playboy centerfold from the year that the table was made. I don't know that for a fact, but I'm pretty sure it's probably true. So anyway, I wanted to talk to you a little bit about what we are going to do with this game. Now, as I mentioned in a previous video about Sexy Girl, the table originally had a slide projector in it, and that slide projector would come on when you reached a 2x multiplier in the bonus scoring area. And then once the projector came on, the images from that projector would be advanced every time you hit one of the targets or dropped one of the drop targets. So that's basically how the game played. Now I'll show you a little bit of the schematic on how they accomplished that. In our game, of course, we're not going to use a slide projector. We're going to use a video display, and we're making enhancements so that as your multiplier goes up, the rating of the images that the game is displaying will also go up. So let me bring up a little PowerPoint presentation that I created just as documentation for how this game works, that we'll package up with the game for, in case it ever gets sold or something, so somebody knows how it works. And I'll I will show you guys how this thing is put together. Okay, here is a part of the schematic for the original Sexy Girl. Now the document is in German, so I can't read German, even though I'm of German heritage and I spell my name with two N's on the end, just like every good German should. But I never learned it. So I made my best guess at how this stuff works. Luckily, schematics are schematics, and they're relatively easy to read, and at least the words in the schematic are in English. So what you have here is the circuitry that advances the slideshow. Now, these slides were actually on a continuous reel of images, probably something around the order of 35 millimeter or something like that, and it was a continuous loop, something like the old Super 8 audio cassettes that would just play in one direction forever. At least that's my belief on how it worked. I don't see any reversing, switching, or anything like that, so I'm pretty sure that all it did was run in one direction. So right here in the schematic is the motor that does the advancing. And over here on the left, there are some switches that they attach to the 6 targets. Now that's the 5 targets behind the 5 drop targets, and I think the 5th key in the Playboy game, the one down on the playfield that has a round target. And they added extra switches onto their switch clusters so that they could use it in their hardware. And then they also added switches to the drop targets and put a little single shot timer in that would fire off a pulse. Actually, all of these things fit into that timer, and that timer would fire off a pulse that would start the motor and run it one cycle to advance the film. So that's the way the film was advanced. Now this is how the light bulb was turned on, and down here at the very bottom I didn't copy all of the schematic, but there is some circuitry that applies power to the projector bulb. And the inputs are game over, 2x, 3x, and 5x. That's the only inputs they used to determine how the game was played. There was a mode switch here that picked one of 3 modes, and the simplest mode was it turned on as soon as the game over light went out. So this game over fed around this way, down to the switch, enabled this transistor, turned on or optic isolator, and turned on the projector bulb. The second way, mode 2, whenever any player hit a 2x, it would latch this latch on, and that latch would feed down here, and it would turn on the screen, and it would stay on. The third mode, which is the bottom one down here, required that the current player had 2x, 3x, or 5x lit. So as long as one of those were lit, then you would be played. But if the next player came up and he hadn't made 2x yet, it would turn the light bulb back off again. Now, realize that the light and the advancing were separate entities. So as you were hitting switches and stuff, the reel was advancing, but the light bulb wasn't on, so you wouldn't be able to see that. Now, obviously, we are not going to do any of that. I showed you guys in the last video the monitor that we are going to use for this. And here is the circuitry that we're going to be using and how we're going to drive this thing. So the Bally MPU, this is the original microprocessor in the Bally, sends address and data out that was destined for the light driver boards in the original game. And we have built a little daughter board that we call the Bally LED board that plugs on that Bally board as a little daughter board and picks up those signals and converts it into serial light controls that control our LED strips that we put in the box. So this unit has a USB plug on it, and I am writing a simple little protocol that transfers the status of these lights over to the Latte Panda that's actually using HDMI to send the data out to the monitor. So the only modification to this board is to pick up the status of the lights and send it over here once a second. And that's it. It's just going to continuously feed the light data over to here, and the Latte Panda is going to do all the work of deciding how the game ought to be played. So if we want to change the rules in the future, all we have to do is go to the Latte Panda and change the rules, because this board is sending 100% of the light data over to it, and from that light data it'll make its decisions. There's a lot of words on this slide, and I'm not going to go through all of them. I've already talked down through the first few bullets here. But the protocol that I have established is to take, there is in the Bally 2 LED board, there is currently a buffer that holds all of the light data, and it's one nibble, 4 bits wide by 16 locations long. And I'm going to just pick up the data out of that already existing array. I'm going to convert it to ASCII by adding it to the value of a capital A. And then I'm going to append a S on the beginning of it for a start indicator, a Z on the end of it for a stop indicator. I'm going to send out the 16 nibbles of data, and then I'm adding up a checksum and sending out a 2-character checksum, which is a byte's worth of checksum along with it. And so down here I show you what that string looks like. So a string where everything is empty would start with the S, and then it goes A. So A's are 0 with a added to an A. So so this is the first nibble, all zeros, second nibble, all zeros, down to the 16th nibble, all zeros. I'm sorry, the 16th zero of all nibbles is there, and then the checksum turns out to be a 1 0. So because I've added all of these digits up, so that's the checksum. If I had turned on all the LEDs and they were all ones, these would all be P's, with the checksum ending up being an AA. And when I read this in on the Latte Panda, I just recreate all of that, check the checksum, and if it's good, I put that into the Latte Pandas buffer to then decide what to do with it. If it's bad, I just trash it and wait for another second and read the one following it. I don't try to recover it or anything like that. It's dynamic enough that it'll show up the next second. As I mentioned earlier, the original system only had 1 rating. I assume that was roughly R. I expect it might have even been softer than that. It might have only been a PG content, but I'm expecting it was like soft R. Obviously, that was done before the rating systems we use today. However, the rating system that we are going to use is when game is over, it's going to have an attract mode showing, and that attract mode is going to be a PG image, small PG image set with some advertising and instruction words or letters added to it. Then when you start playing, you will be in PG mode. Now this is fully clothed bathing suit sort of images. I declared a PG video, although in my current design I'm not using any video in PG mode. You get to the R mode before you could ever get the videos turned on. And I don't know if, yeah, I mentioned it in the next slide, so I'll wait till I get there. So there's R-rated images and R-rated videos, X-rated images and X-rated videos, and triple X-rated images and videos. We're going to build some kind of locking mechanism in here so that if the table is just sitting out and anybody can walk up and play it, it'll probably cap out at the R mode and it won't go any higher than that. But if you know how to enable it, it will get higher level videos and images displayed. So here's the current rule set that we're looking at. So if the game over light is on, we'll be in attract mode. If the game over light is off and the bonus has reached 9,000 or higher, it'll start displaying you PG images. The 20x super bonus just toggles the mode between images and videos. So if you get up to 20x and light the 20x super bonus, you flipped it into video mode. If you never get to 20x, then you never get videos, you only get images. So if you have the 2x multiplier on, you get R-rated videos or images. If you got the 3x multiplier on, You get X-rated videos or images, and if you get the 5 times multiplier on, you get triple X videos or images. And once a image has changed, we lock the change for 20 seconds. So whatever the image or video is that's playing will stay for 20 seconds before it can be advanced to the next image. And there's going to be just a library of each of these types of images, and you'll randomly choose from one of those. I mean, the program will randomly choose and display one of those. So that's it. That's how this game is going to work. I've got the software already written. I decided to spare you guys and not show it to you because so many people just don't care about the internals of this stuff. If anybody's interested, let me know, and I will certainly show you the software. The primary software is written in Visual Basic for the Latte Panda, and right now I'm developing that on the same machine that I'm recording this video on right now, but it'll be ported over to the Latte Panda once it is fully working. I have the communications protocol completely working and tested. I have the display protocol tested to the point where it displays videos or images. All I need to do is fix up the software that pulls in the directories of each of the directories and chooses when to play and do the little bit of gameplay. It's an hour or two of programming left to do, and I should have an alpha version of this ready to start testing. Now, unfortunately, because the nature of the images, unless I build a fake library with all PG images in it, I won't be able to show you guys doing that. And I might do that. I might build just an image with different people in it or something. But even that, I mean, most of the images I'm using are probably copyrighted. They're for our own personal use and not for sale or anything. So it's okay for me to use these. But if we were going to ever make a product out of this or try and sell it, we'd have to contract somebody or pay royalties to somebody to get legal images to put on this. So anyway, like I said, we probably won't be able to show you much of that on YouTube because they are somebody else's images. So with that, I'd like to thank you for watching, and hopefully we'll see you later.